Now in this video, we want to talk on Fourier series for periodic function of period 2 pi. And our first example will be find the Fourier series representing f of x is equals to x for the range of 0 less than x less than 2 pi. And since it is 0 less than x less than 2 pi, these are the formulas we will be using. Okay, and this is the formula for Fourier series itself. So the first thing to evaluate is a naught, and from here we can see that a naught is 1 over pi integral of integral of f of x dx from limit 0 to 2 pi. This is 1 over pi integral of f of x dx from 0 to 2 pi. And now f of x from the question is x, so we have it to be 1 over pi integral of 0 to 2 pi of x dx. Moving further, when we integrate x, we have x squared over 2 from range of 2 pi 0 to 2 pi. And when we include our upper limits and also our lower limits, we will be left with 1 over pi for 4 pi squared over 2 minus 0. And we have 1 over pi to 2 pi squared. As 2 we cancel 4, we made 2, and this will give us 2 pi. So we have that a naught is equal to 2 pi. Now the next thing to do is to evaluate an. And from our formula, we have that an is equal to 1 over pi integral of f of x cos nx dx from 0 to 2 pi. An is equals to integral 1 over pi integral of 0 to 2 pi f of x cos nx dx. Now thereafter, we substitute our f of x. So an is 1 over pi integral of 0 to 2 pi. F of x is x cos nx dx. Now how do we go about this? We have two functions u, v. How do we integrate u and how do we integrate uv? So u, v, the integral of uv, we will have u v1 minus u prime v2 plus u prime prime v3, and it continues, where u prime is differentiating u with respect to x, u prime is differentiating u prime prime is differentiating u prime with respect to x, or we can say it is the second differentiation of u. And v1 is equal to the integral of v with dx, and v2 is the integral of v1 with dx, v3 is the integral of v2 with dx. Now moving on, our u is x and our v is cos nx. Henceforth, we can say that when we differentiate x, we have 1, and when we differentiate further, we have it to be 0. Also, in our v, we have to evaluate v1, which is integral of cos nx dx. Now going backwards to our first video where we integrate cos nx dx, and then we will have sin nx over n, and integral of cos nx dx is equal to sin nx over n. To evaluate v2, we integrate v1, so that will give us sin nx over n with dx. Now integrating sin nx over n, we have it to give us minus cos nx over n squared. We have it to be minus cos nx over n squared. Now we apply the formula we have, and we can now say that an is equal to 1 over pi. We start with u, which is x, followed by v1, which is sin nx over n, minus u prime, which is 1, then v2, which is minus cos nx over n squared. And there will be no need for us to continue further with u prime prime because it is 0. So we have this from a range of 0 to 2 pi. Now we can simplify further, and this is 1 over pi of x sin nx over n, plus, because minus we cancel, we multiply minus to give plus cos nx over n squared from a range of 0 to 2 pi. And now we deal with the limits, starting with the upper limit. Wherever we see x, we put 2 pi over n, and wherever we see x again, we put 2 pi over n squared. And now onto the lower limit. Wherever we see x, we put 0, and wherever we see x, we put 0. Now we can see that this 0 is multiplying this, so everything here turns to 0. And we can as well recall that sin 2 pi cos 2 pi, sin 2 pi to be 0, cos 2 pi to be 1, sin pi to be 0, and cos pi to be minus 1, sin pi over 2 to be 1, cos pi over 2 to be 0, sin 3 pi over 2 to be minus 1, and cos 3 pi over 2 to be 0. This is what we did in the introductory video. So we can see an effect of sin n 2 pi, and that means it's any variable multiplied by 2 pi, and since sin 2 pi is 0, that means everything here is 0. So we are left with an is equals to 1 over pi cos n 2 pi over n squared minus, okay, cos n 0 over n squared. Now, how do we proceed from here? We have to evaluate an when n is even and when n is odd. Okay, so when n is even, we will have terms of cos 1 2 pi as regarding this. We also have cos 2 2 pi, and as well as cos 3 2 pi. Okay, when n is even, that means n is 2 4 6 2 4 6. So we have this to be cos 4 pi, this to be cos 8 pi, and this to be cos 12 pi. Now all these are multiples of cos 2 pi, and since cos 2 pi is equal to 1, everything is equal to 1. And when n is odd, n is equals to 1 3 and also 5. So we have cos 1 2 pi, cos 3 2 pi, cos 5 2 pi. Now we can see that they are all variables of 2 pi, just as we have here. So everything also is 1. And that is for cos n 2 pi. What about for cos n of 0? Cos 0 in itself is the same thing as cos 2 pi, so which is 1. Okay? Cos 0 is 1 and sine 0 is 0. Let's add it here. Sine 0 0 and cos 0 is 1. Okay, since they are now similar, we can see that this will take the same format as this has taken. So in essence, we say that an is equals to 1 over pi, and cos n 2 pi is equal to 1 over n squared, and cos n of 0 is also equals to 1 over n squared. Now this will be equals to 1 over pi. 1 over n squared minus 1 over n squared is 0, and that will give us 0. So an is equal to 0. Now we have been able to evaluate a naught to be 2 pi. The next thing to do is to evaluate bn. And bn from the formula is 1 over pi integral from 0 to 2 pi of f of x sine nx dx. And remember, we are dealing with f of x is equals to x. So this will give us 1 over pi integral of 0 to 2 pi of x sine nx dx. Now we recall what we did with u and v, because when we integrate uv, we have u v1 minus u prime v2 plus u prime prime v3, and it continues. So when we evaluate u to be x, we know that u is x and v is sine nx. So u prime is 1 and u prime prime is 0. v1 which is integral of sine nx dx. Okay, when we go back to video of integration sine nx, we'll have minus cos nx over n. And when we want to integrate cos nx, we'll have it to be sine nx over n squared. So integrating sine nx, we'll have minus cos nx over n squared. And v2 will be integral of v1, which is integral of minus cos nx over n. And this will be minus, bringing the minus constant outside, cos nx over n dx. Integrating cos nx over n dx, we'll have sine nx over n squared, and the minus sign comes downward. So we have this to be v2. So we can henceforth continue solving bn, which is 1 over pi, and we apply the integral formula of uv. So we start with u is equals to x, v1, which is minus cos nx over n, minus u prime, okay, which is 1, and v2, which is minus sine nx over n squared. And we stop there because u prime prime is 0, from 0 to 2 pi. So solving this now, we have it to be 1 over pi into minus x cos nx over n plus sine nx over n squared, 0 to 2 pi. So in essence, we put the upper limit and we also put the lower limit. So applying the upper limit, we have it to be 1 over pi from minus 2 pi, because wherever we see x, we put 2 pi plus sine 2 pi over n squared, and then we subtract it from the lower limit. That's minus 0 multiplied by cos n of 0 over n plus sine n of 0 over n squared. Now, as we go further in Fourier series, some terms come into plain sight. So we know that this is 0 multiplied by this, so everything becomes 0. And where we recall that what we have before, that sine 2 pi is equals to 0, cos 2 pi is equals to 1, sine pi is 0, cos pi is minus 1. And when we apply even and odd to it, we come to a conclusion that this is also 0 because of sine 2 pi. Sine 2 pi is 0. And also sine 0 is 0. So this turns to 0. So in return, we are left with this. So this gives us 1 over pi into minus 2 pi plus n 2 pi over n. And we have minus 2 plus n 2 pi over n. While solving for an, we saw that the table for cos n 2 pi and also the table for cos n 0. And we saw when n is even and when n is odd, we have both 1. So cos n 2 pi is equal to 1. So this will give us minus 2 over n. So we have bn to be minus 2 over n. Okay? So we call the answers that we got that a naught is equal to 2 pi, an is equal to 0, and bn is equal to minus 2 over n. And we want to insert it into f of x is equals to a naught over 2 plus summation of n is equals to 1 to infinity of an cos nx plus bn sine nx. So inserting them, we have a naught over 2, and since a naught is 2 pi, that will give us 2 pi over 2 plus summation of n is equals to 1 to infinity. An is 0 multiplied by cos nx plus bn is minus 2 over n multiplied by sine nx. So this turns to 0, and we are left with 2 pi over 2 is pi plus summation of n is equals to 1 to infinity of minus 2 over n sine nx. Now we can begin to insert our values of n from 1 to infinity. So in essence, we have f of x is pi plus when n is equals to 1, this equation, put wherever we see n, we put 1. So plus minus 2 over 1 sine 1x plus whenever n is equals to 2, minus 2 over 2 sine 2x plus when n is equals to 3, minus 2 over 3 sine 3x, and it continues in that order. So we can have it to be pi minus 2 sine x, okay, minus 2 over 2, give me minus 1 sine 2x minus 2 over 3 sine 3x plus triplet. Now we have now solved the question of the Fourier series of f of x is equal to 1 from a range of 0 to 2 pi. In our next video, we will talk on solving another question for periodic function of period 2 pi.